welcome to part 2 of this repair video. In part 1 I stripped this dead monitor down and replaced some bad capacitors. My experience with my other identical monitor suggested that that would be enough to fix it, but with hindsight I really should have tested the power board before I put it all back together. So now I have to take it all to pieces again to try to figure out why it still doesn't work. Now I'm not a power supply expert and I don't have schematics, so my plan of attack is to try to test individual components to eliminate as much as possible. And this black line denotes the divide between the high and the low voltage sides. This was our damaged capacitor, and as you can see it's on the high side. It's going to be difficult to test some of these components without taking them out. So we're plugging it in. Yeah, I'm getting nothing on the output stage. We have a pretty high voltage. It was reading 330 on the cap, but there's clearly a discharge component in there designed to bring it down when it's not in use. So we've got something on the high side and nothing on the low side. So I've tested all of the passive parts, the obvious stuff. So I'm now getting to the point where it has to be silicon. So I'm seeing an 8-pin device on the bottom of that and a transistor. Well, I can check a transistor, and then there's this one which I've checked, and then these two. here's our bridge. The two middle pins are these two, and I think which one was minus and which was plus. That one's the positive, so you think of it as that way round. And I can measure our diode setting. Hopefully I can prove whether the diodes are working or not. So if I go to any of the AC and the plus side, one way I get nothing, the other way I get half a volt. That's good. And if I go to the other AC, that's checking a different diode. Same result, roughly same result, yep. And I can do the same thing to this side. I'll get nothing one way and nothing the other. Ooh, and something the other. Yep. And again from this one to the here, nothing one way. Yeah. All four diodes in there are intact. So, what does this tell us? It tells us we didn't need to do all that soldering, but so. Now wait, before I solder that back, let's quickly check this. This looks like it's two coils, which would mean nothing between those, nothing between those, nothing between those, but this way I have something between 001. 001, okay. It's a winding. Let's put this back. Which way was it? You see the black square? That denotes this little corner. So the next most likely point of failure is the FET, and yeah, I know I could take some measurements and see if there was anything wrong before I take it out of circuit, but to be honest, I prefer to take the measurements off board. It doesn't appear to be a short across any of the pins, which is an encouraging sign. Very often when these fail, they go to a short. So the usual thing is for this pin to be shorted, for the rest of them not to be. Alright, let me show you what I'm doing here. This is gate, drain, source. I'm putting the negative side of the probe onto the source, and then the positive, firstly we touch it to the gate. That should charge up the internal capacitance, and then measure on the drain here, and you can see we have a reading of high impedance. And now I'm going to take my finger and I'm going to short the source to the gate just with my finger, and you see now the reading's changed to a different value. It only switched between high impedance and very high impedance, but it is switching. So when I measure this diode, it's shorted, and it may not be the diode at fault, but I feel the need to test further. Alright, I've lifted that just about C here. You see that it's actually lifted off the board. So now we will get the measurement, and if it's okay, I'll stick it straight back down again. And it's fine. Here's a classic example of how not to ground a scope. I really should know better, but I connected the scope ground to something that I thought was ground but turned out not to be. Luckily for me, the flash and bang was just a capacitor discharging and no damage was done, though it did mean I had to go back and recheck lots of the components that I'd already tested. Now what I was trying to measure was the output of the PWM IC, pin 5. There we go. 50 Hertz. 50 Hertz. That was just mains. 50 Hertz. Well, it's not supposed to be 20 milliseconds. That was 50 volts per division. And there was about 8 of them. That's just... that doesn't seem right. So, some time has passed since I looked at this last. Reason being, I decided to order up some of the silicon parts. Now I know I tested most of them, in fact all but one. These are PWM controllers. This little 8-pin device here. I really couldn't get any sensible measurements from that. I did take the time off camera to go through every component on the board, looking for a sanity check basically. Resistors I measured across, allowing for the fact that they were in circuit, they were okay. Capacitors, well, a lot of them, especially the surface mount ones, you can't read off the value, so you just have to look for a short. Diodes are easy to test, transistor packs and so on. So the first thing I'm going to try is a new one of those, and then we'll power on and see what happens. Right, let's see about getting this chip off. In fact, this is the first time I've used this gun since repairing it. video yet to come. So yeah, everything looks in good condition. I just want to clean up solder and put the new IC on. There is the new IC in position with one floating leg with a bad track, but that leg was not connected. I guess I could look on the spec to see what pin 7 does, but it'll probably be an NC. It's marked 200A6. It's actually otherwise known as an NCP 1200A. And as you can see, that pin with the broken track, broken pad, was a no connect. So it's all fine. Alright, so this is the smoke test. I'm going to plug it in. If we don't get any smoke, I need to measure the output. I'm guessing it's across those capacitors there. Right, don't blink. I'm going to connect the power now and watch for the bang, particularly from this little thing. Alright, no bang. I need to bring this thing into view somewhere. I'll just keep it there and measure, okay? Damn it, we've still got nothing. Wait a minute, guys. I think my crock clip was loose. And across the capacitor here, I've got 18.9 volts. And 19 volts is what we expect as the output. I believe that's working. Don't think we saw that before. Right. Time to reassemble. And I'm sure you're tired of seeing these boards go in and out of the box, so we'll cut this short. Okay, here comes the fun bit. Look at that, you can just about make out from the glare. Dell, it's powering on. It's running. We have a winner. Okay, I'm going to put the box back together and we'll be done. Yep, we're up and running. One last thing to do, both of these monitors are sagging forwards as if the spring tension on the stand isn't right. So I want to take this apart to see if there's an adjustment. So a bunch of screws and a bit of time later. Here's what it looks like on the inside. That's the spring which supports the weight of the monitor. And this nut here is what needs to be tightened in order to stop the sagging. I've turned it, it's a hexagonal, I've given it 1/6 of a turn tighter clockwise. And before I did that I could push this down by hand, and while I can still do it, it's really hard to do now. So I'm going to try that, see if that works. If not, I might have to come back and loosen it a bit, but trial and error. And so that's both monitor stands adjusted, and I'm really happy because both monitors are up and running and they even stay in the position I put them in. Hopefully I'll get a few more years out of them before I need to upgrade. That's it for this fix. See you in the next one.